Oh, hey, what's up, YouTube? It's Brian House here for Housework. And today we are continuing on with the 2x72 belt grinder build that you've probably been following along. And if you haven't, this is a series of videos that I'm putting together in designing and prototyping a 2x72 belt grinder, primarily for metalworking, knife making, and other things. But I truly believe in the 2x72 as one of the most important machines you can have in your workshop or garage. Regardless of whether or not you're a commercial entity, I think everyone should have one of these in their workshop. So unfortunately, they are a little bit expensive to buy brand new, and it's a bit restrictive to buy one if you're just starting out building your workshop out and putting things together. I know I looked at a couple of them that were in the $2,000 to $3,000 price range, and I thought, yeah, those are awesome, but I'd really love to have one of my own. So I went and bought a whole bunch of tube steel and put one together with a treadmill motor. And that project has since evolved into this behind me here, which is a standard 2x72 sort of home-built job with an AC 2-horse motor and a VFD. The powertrain, in my opinion, is super important. So when people ask me about, hey, why don't you use a treadmill motor anymore? I really don't use it because of a couple of reasons, and there's another video on that, and I'll link to it right up here. You can go and check that out. However, the long story short is that the powertrain is so important in this thing, you might as well just go ahead and spend the money on doing it right and doing it with an AC motor. There's a whole different conversation there. We won't have it in this video, but I really do truly believe in it. So anyhow, that is what we are doing. So in the last video, you saw me profiling out the stanchions, drilling the holes through those stanchions so that we could run a threaded rod through and start our fabrication of the hinges. And I did not have success in carving out that C-channel the way I wanted to. And that C-channel really is just there for a locking nut so that I can actually turn and tighten it down. So when the thing turns 90 degrees, you can lock it in one position and so on. It's a very simple mechanism. However, without a plasma cutter or any sort of really advanced machine equipment, I was not able to do that properly. So I went out and bought a rotary table and I threw it on the mill. And after quite a lot of fiddling around, I was able to get it centered properly. I made a custom little pin jig to kind of go down on the inside of it to hold everything in the middle. This process was frustrating, but I also learned a lot. So you'll see that in this upcoming video of me carving out those C-channels and making it work. I found that process to be pretty satisfying once I understood what I was doing. You know, it's one of those things where I'm the type of person that learns by doing. So I went online and obviously read and watched videos. People had submitted videos to me to watch in regards to this process to kind of do it without a rotary table. And I didn't have all those little nuts and bolts and pieces and the T-handle and everything. By the time it came down to it, to buy a cheap rotary table made a lot of sense. So I went ahead and did that and put it all to work for me, and you'll see in the video upcoming of how that turned out. So the goals for today are really going to be get those C-channels carved out and ready for the axle to go through so we can get all that stuff tacked together. Also, I'm profiling out and cutting the sheet of 3/8 inch steel that will hold the motor, and it goes along the two tube steel receivers that hold the tooling arms. So that's a process that I've never done before because I need to transfer the holes from the motor to the steel plate and do it in such a way that I don't screw it up, because those holes are really important where they are and where they're located. So anyhow, come along with me and we're going to spend a little bit of time here in the shop. We're going to create these pieces of steel and get it going right here on Housework. Screw it. Let's do it. So we've put in a good 6.5, 7 hours in on just the plate and a couple other things today. And I'm tired and I'm a little bit exhausted from this process. I think I'm more mentally exhausted from trying to figure out where these 4 bolts go in this motor mounting plate. I know that sounds dramatic, but man, I had the blueprint and everything. And in fact, as you saw, I made a nice little template, which would make sense, right? That this should just work without a whole lot of energy or brain power. But the first 2 holes that I drilled were completely wrong. They were just misaligned. They were off quite a bit. So I ended up filling those holes with welds and then putting it all back together and then slowly, one by one, drilling the holes out again. And I've gotten to where I am today. I don't have the right hardware for this. I gotta go stop at the hardware store later today and get the right bolts for this. But the slightest bit of measurement off and you're screwed. And my caliper, like a moron, I did not have it zeroed out properly. So I was measuring everything with the caliper going, the blueprint says 5.875, yet I'm reading out 6. Why am I reading 6? I'm thinking, the blueprint's wrong. It's the blueprint. And then I'm like, did you zero out your caliper? By then it was too late. I had already drilled both holes and felt very defeated, but you know, had a cup of coffee, looked at it again, ground it down a little bit, put some weld in there, and started all over. It's not the end of the world. That's kind of the cool thing about working with steel. You screw something up, as long as it's not something too bad, like a major cut where you're, you know, completely off, you can fill a hole with weld and then go back and redo it. So, and I'm comfortable that it'll be strong and everything. I use the right voltage on the welder and stuff. So you also saw me drill 6 holes right here in this long piece that goes up along the receiver tubes. I've decided to put some rosette welds in there. I think that's how you pronounce it, rosette welds, where you place your piece down underneath and then drop a weld down inside. These are flared out just slightly on the bottom side. So just to add a little bit of protection, maybe a little bit more strength. I am going to do a bead down below and a bead on this back side and a couple of pop welds at the top. Don't think I'm going to do any on the front. I don't think it needs it. I think that'll be plenty strong. So yeah, we are you know, making pretty decent progress. Not as fast as I'd like. I just feel like in fact, I felt like I was rushing a little bit because the holidays are coming up and I might not be able to produce as many videos. So I was kind of rushing on this plate and I totally regretted it. I messed up those bolt holes. I didn't do something very simple like zeroing out my caliper, and it set me back like 2 hours. So I just took a breath, made a coffee, took another look at it, and then approached it again and started over, and everything was fine. So I'm surprised at how easy it was to drill that 4.5-inch hole in that steel plate. After I figured it out, I had the plate up a little bit from the mill table, and it was vibrating a lot. So by dropping it all the way down onto the mill table, I actually solved that problem and it went through pretty easily. It was probably the most annoying sound I'd ever heard in my entire life, but it actually cut through it, and unfortunately a little bit into my mill table. I'll have to fix that again, probably with a welder. And yeah, again, I was rushing, trying to videotape, create this thing, and you know, it just goes to show you, don't rush while you're doing this. Also, in the back of my mind, I'm thinking, in about 5 minutes, that Langmuir Systems Crossfire Pro could cut this out with insane accuracy. What took me 6.5, 7 hours would take that thing about 5 minutes. So can't wait to get that thing. If you got something out of today's video, don't forget to leave me a thumbs up. And if you're not already subscribed, hit that subscribe button. I've got some big news. I actually gained 2 new patrons this month. Andy Miller from Boatworks today. Andy and I have been friends for a long time on YouTube and just recently met in person a few weeks ago and had lunch. He's now a patron of mine and I really do appreciate it, Andy. And Ron Crandall, thank you so much. All your comments, your suggestions and everything. You've signed up for a $5 a month pledge and I do appreciate that. You have no idea what that means to me. It's actually makes me feel like I'm going in the right direction, that it's an affirmation, if you will, that I'm doing the right thing. So thank you so much, guys. I do appreciate you. Also, there are links down in the description. Everything you see right here in my workshop is available in my Amazon store. I've got it broken down in a nice little category so you can find anything. That is a free way to support my channel if you don't want to do Patreon. Click through to those links and buy something and I get a small little commission. As always, guys, if you do leave me a comment, I read and respond to all of them. They're very valuable to me, so go ahead and leave them as long as they're productive. And yeah, that's pretty much it. So thanks again, guys. My name is Brian House, and this has been Housework.